Hi, I'm Gerben.
Hi, I'm Rick. Gerben, we have a podcast, the Betatalks podcast. I do that together with Oscar. So if you haven't listened to the podcast yet, look it up. It's on all major streaming platforms, so you should be able to find it with just the Betatalks term. And we had a guest recently who inspired you for today's Betatalks, right?
Yeah, it inspired me a lot, and you also with Oscar on your podcast, number 37, which was with Isaac Abraham, and he with his company is doing a lot with functional programming, and he was talking a lot about F# and also using F# as their main tool. Maybe you, like me, has used or has looked at F# sometimes, and you think, okay, this is a really cool language, really declarative. Maybe we could use it, and then you can use it in things like business logic. But there was not really a way to have a full integration of that language, and then to keep up with two languages in the project with a team, it's difficult, and then you can switch back really easy.
Yeah, so you looked at it, wow, this looks awesome, let's go back to C# where we know how to do stuff.
Yeah, you do some demos, and you look up some templates and you think, okay, this is really cool. And you do the standard hello world functional stuff with functions and so some basic stuff. Then you think, okay, but now I need to build an API or something that we build in our businesses. So, yeah, but I was inspired by that talk, and Isaac was also talking about the ecosystem, and that made me make a journey in F# ecosystem. Yeah. And I want to show you and the viewers that journey and to see what's there in F# and what cool stuff can be built right now.
Awesome, because I haven't made the time yet to actually dive in. I've been meaning to do so for, well, maybe even a couple of years. So I'm really happy that you did, and you're going to share what you found.
Yeah, I'm going to show you. But first, before we start and dive into the ecosystem, first we'll have a short introduction about F# and then about the functional concept that's underpinning F#. So one of the really cool resources if you want to start learning about F# is obviously the Microsoft documentation, but in particular about F#, I think it's a really good documentation, really going from a entry level into more deeply into the language. Mm-hmm. So if we look at what is F#, one of the most important things is that it's a universal programming language, so a general purpose programming language that could be used for anything, from data science to UI to web app. Everything you want can be done, but as we all know, if we want to build like an API UI, it's good to have some frameworks or libraries you can build and depend upon. Yeah. Sure, you can make them all yourself, but then you have hard work making that.
And you said it's a full-blown language. If I look all the way back to the beginning in the first introduction of .NET, so versions 1 and 2, and the first versions, it kind of felt like we have C# and we have VB.NET, and oh yeah, there's F#.
Yeah.
So it used to be a bit underdeveloped, maybe even. Yeah. But things have changed, right?
Things have changed, and what we see happening now is that even concepts from functional programming sharps are getting back into like C#, for instance, record types and immutability, because in functional programming there's some really strong concepts that can make it, in my opinion, a lot easier to read code and also to even present that code to somebody that's not really a programmer, because some concepts are just easier in F#, at least for me, because if you look at, I have here a simple code snippet. For instance, instead of variables, you bind values or functions to a name. So with that let binding, so it's a immutable label. It's not really a piece of memory. It's an immutable label, really different than variables. It's the same if you do with an array, with a list, with a string. It doesn't really matter, or a function, and they all look the same, and it's one core concept. And then if you want to do something, for instance, with that array of names, you have a way to compose functions together in a way that's more readable and more natural, because if you think about it, let's say you have a list of names, and then you want to get the greeting for that name, and then you want to iterate and print over. That's the way you normally think about it.
Yeah.
But if you go back to, for instance, C#, then you have to write it the other way around.
Yes.
I mean,
Yes.
you first have to do the iteration, then the greeting, and the names, they come into the middle. And if you want to show that to somebody, it's really difficult. And this kind of the pipe operator makes it really cool to compose those functions. And it's an operator, but it's built on top of functionality of functions being first-class citizens and being able to compose and combine those functions.
Yeah.
On top of functions, C# has a really powerful type system. So if you're going to think about a program, most of the time you should start with the types. What kind of data do I have? And then on functions that do something with the data, mutate it or in any other way do other stuff with it. So it has a few really cool concepts. One of them, I think that's a really cool one, is discriminating union types. But in essence, that's you define a type that can have multiple values. But those values are all typed, which means that the language server can help you if you want to match on it, and if you want to make sure that you have all cases, even IntelliSense on what kind of possibilities there are. And it's also a really cool way to make your program readable, because like you see here, we define a type, withdrawal result. You see really easy to grasp concepts like, okay, is it successful or not? But that's not merely like a string or an enumeration. It's a type that's defined in your type system that you can reason about and build your functions on. So what you can see here, for instance, is that we can match on that type, and the compiler makes sure that you actually have everything.
Yeah, so that enables things like IntelliSense to really improve your code for you,
yes.
or at least tell you where you need to improve, and maybe even have things like Autopilot or Copilot could also generate this for you.
For sure. But also what it makes really clear is what kind of type is going into your system. I mean, in C# we have to deal a lot with null reference. At least we had to deal a lot with them. In F# and in most functional languages, you have a option type or maybe type, and that type can be a value or no value. But that no value, it's still a type.
A result.
It's a result. So your function returns a option, and if you want to do something with it, you need to do something with both of those results. Yeah. So you know, okay, from this function, something or nothing can be returned, but that instead of null being really nothing, like you can't even reason about, it's not a type, you now have something that you can reason about. And the same goes if you have a function that only is doing stuff, but it's not returning a value. It's still returning a type, so not a void, but it's returning
nothing.
Unit type. Yeah, in F# it's called unit, but you can see it as nothing or an empty set, or you can call it all kinds of things, but it is a type that you can reason about.
Nice.
So what you can also do is with types you can go into a more object-oriented style. At least you can simulate objects. Types can have members. That means that you can do stuff with state, but that's all in the overarching concept of types. So you don't have something like classes or objects. It's just types, and functions. A lot of functions.
Okay.
So that's some concepts about F#. It's good to get back to the foundation, and also in the documentation of Microsoft there is something about functional programming concepts in F#, and that's more like the underlying functional layer, the fundament. So again, it's about functions being the primary constructs, expressions instead of statements, which means that everything should return a value and not be something that does not return anything. Or change something in your program without you knowing it. It's about immutability.
Yep.
In general, when you use that let binding, a name is immutable. You can do mutable stuff, but then you have to specifically add a keyword. So everywhere in your code you see, okay, now I'm doing something with mutability. Sometimes it's necessary, most of the time it isn't, and that's something that when you go from a more imperative language, so a language where you have to declare exactly what's going on, what has to be done, C#, for instance, to a more declarative language like F#. It is a concept switch. So
it is.
Patterns are different. You should think different about solving problems, and most of the time that's the most difficult thing to do, to switch in your head those patterns.
Yeah, I can imagine. I mean, looking at the code, I understand what it's doing.
Yep.
Writing it yourself will force you to actually think about it in the way that functional programming needs to work.
Yep. Yeah, for sure. So that are the functional concepts. Then something. Okay, if you ask a functional programmer. Okay, so what kind of patterns you use? Most of the time say functions everywhere, but it's true. I mean, in object-oriented programming, we have devised some patterns to make all kinds of things easier, better to reason about. Functional programming, in that sense, are easier because they have types and functions. Yeah, they have types and functions, and so they have objects and they have things that transform those objects to other objects.
Yeah.
So that's what functional programming is all about.
And resistance is futile.
Yeah, you cannot resist its functions. I think it's really cool that it's also on the visitor pattern. I mean, why on that one? But could choose anyone. But that's cool. So design patterns. Now onto the ecosystem.
Yeah.
So the first one that I want to show you is Farmer. Farmer is a way to declaratively define Azure resources, and this definition will render to a ARM template.
Okay.
So that means you have typing support, everything is typed, auto-completion is there. It's a really clean and simple way to write your resources. In contrast with Biceps, which is also a domain-specific language, which also renders to ARM, F# gives you a full general purpose programming language. So you can do everything that you can do in it's just a program that can output a ARM template.
Yeah, that's actually really powerful as far as, for instance, build pipelines and deployment pipelines goes, right?
Yeah. It is. You can host it just in any agent, outputting a ARM template. You can do all kinds of stuff. For instance, one of the things that they don't support in Farmer, or at least they don't want to support, are parameters and variables. Mm-hmm. You can specify them in ARM, but they say, okay, you have the powerful concept of F#. You should use that instead of a different concept that you need to specify another document. Just build it in your program in F#, render it to the ARM template without the need of, for instance, a parameter.json file or something.
Yeah. You
just have one a template that...
And that's the truth, and that's where your config is.
Yes. Yeah, so I prepared a small demo for you to see how small the definition is. This is a web application definition. You can see that we have typing support, so we know exactly what you can use in this resource. And even if you do stuff like you want to provide a different SKU, you get all the options. And yes, so you have to keep up with at least the developers, maintainers of this project needs to keep up with all those resources. I mean, that's important. But that's the same as, for instance, Biceps. They also have to keep up with.
Yeah, of course.
Yeah.
I actually saw the My Web App change from a object to a web app config.
Yes, I think that's the plugin that's Ionite. It's running on the background, so I think then they get extra information from the language server, so that the typing is correct. I mean, this is also the strong typing, so you know that it's a web app configuration. That's the output of this. It's not a function; it's a computation expression. But that's a really deep dive into F#. It's a special thing about F#, but it's still typed and So what it then outputs, it outputs this ARM template. So it's like 160 lines of ARM with all kinds of defaults. You can change. Obviously, you can change all those defaults. Yep. You can add and delete linked resources, everything. So I think this is a real cool start into our journey of the ecosystem, and that is Farmer. So the next one, and that's a really important one in the whole ecosystem, at least if you look about web applications, it's Fable. And Fable is a F# to JavaScript transpiler. So it means that Fable is able to get F# code and then transpile it to JavaScript code. Almost anything that you can do in F# works. There are some exceptions.
Yeah, and then is the because the Farmer name was F# ARM, right? And then you get Farmer. This kind of sounds like, is it F#able? Affable?
I didn't think about it, but yeah, is it F#able? Yeah. Yeah. So also the goal of this project is to not only transpile to JavaScript, but also to other languages. So Rust, for instance, or other kinds of language. Yeah. So you get F# to anything.
Nice.
That would be like really cool.
It's kind of a big goal to.
Yeah, it is, but yeah, they define a really flexible system so that it can be easier to add other languages.
Okay, cool.
Yeah, so that's Fable. Well, what I want to show you is if you go to the Fable website and then to the REPL, so the read evaluation print loop, you get a nice website where you can see that F# code is transpiled to JavaScript code. So you can see the JavaScript code itself is pretty clean. It's nice. But the cool thing about this is that, I mean, that's really inception. The F# compiler service itself is transpiled by Fable into JavaScript. So inside of this browser, the F# compiler servers are running with IntelliSense and everything, and compilation happens in your browser. It's not sending to a service or something.
That's actually pretty impressive.
And getting the output back. No, it's running inside of your browser.
Nice.
So I think that's a really cool thing.
Yeah.
And also for Fable, a small little demo to show you what's possible. Let me open up Farmer. So you can see here that you can also do some basic, at least some basic stuff with the DOM. Do that. Yeah, in this case, it's just to show that Fable is able to also communicate with the DOM and output JavaScript.
Yeah.
So because it's output is a JavaScript project, you need to start it with npm start. And then you can see that a lot of stuff is happening. So F# is compiling to JavaScript. You can see that it's getting the project. It's setting stuff up. It's running on Webpack. So it also got things like hot module reloading, and if you change something. So if you then look at the website, then we have it's a simple demonstration website.
But if it works?
If it works, it works. And on top of this, you can add all kinds of abstraction layers. I mean, the same like in JavaScript, you have React. You also are able to use React for F#, for instance.
Okay.
So that's Fable. Let me close Fable for now. The next one is Elmish, and that's based on a project called ELM. It's a functional JavaScript library that supports the model view update design pattern. It's a little bit the same as with Redux. It's a store that you put actions into or messages, and the store gets updated, and you get a update back. Yeah, so Elmish, and we will see a bit later that Fable, Elmish, they are combined in a nice package together to provide you the full developer experience for a client and a server model.
Okay, cool.
With a cool name. With a cool name. So the next one that I want to show you, that's also because we may want to build some APIs.
Yep.
It's Saturn. Saturn is a MVC-like framework. It has the same things that you expect from MVC. I mean, routers, controllers, views. It works the same. If we have, let's see, a little bit of code. A really basic one is to have you define an application with a router. So that's a really simple one. A more detailed one is you start with a type.
Yep.
You define your API endpoints, and then you make your web app with the routers. So a really cool, clean, declarative way to define APIs.
And it kind of looks like the people who have created ASP.NET minimal APIs might have been inspired by what they saw here.
Yeah, you see the same kind of project, so we get back to the more declarative way with all the ceremony around it. You just want to see and define the APIs and the endpoints and let the framework sort out how to combine all those things. Yeah. So, yeah, I think they did. But with this you get a full MVC framework.
Cool.
So that's a really cool one. So the next one I want to show you is the safe stack. So here we combine everything together. Yeah. So we combine Saturn, we combine Fable and Elmish, and the A stands for Azure. So we can also access Azure resources. Mm-hmm. So we have the full circle of client and server. A little demonstration again. All these projects they have really cool and easy to use templates. So that means you can install with .NET just a template. You can run the template, and then you get the boilerplate code. There's also what we have here for safe. You can see both the server and the client. So you have something on the server and you have something on the client. In this case, to communicate, they use a remoting that is provided by Fable, and it goes over WebSockets. So you just define types and you define functions, and then in a really functional way you can call that, and everything on the back is handled by the remoting.
But just for me, I mean, remoting used to be a term like 15 years ago when we had ASP.NET. We had remoting. Currently we have gRPC, which is remote call procedure call. Is this something that is more like the first one, so the old one, or is this more like gRPC? It's
more like gRPC, but it's a at least for this template, it's an opinionated way to call the backend. But by using this, you get a really clean interface on the code side. So it is not really interoperable. At least you can import libraries to talk with it. It's not like it's exposing a REST API. It's a WebSocket, and you synchronize objects over it. But in return, you get a really clean interface on the coding side.
Yeah, that's actually pretty nice.
So yeah, that's really cool, I think. So that's how we combine everything together in the safe stack. Yeah, and I think this is for people who want to start out. This is a really good way to get to know the whole ecosystem, because it packs everything together.
Now, as far as I'm concerned, I mean, if you look at a language like C# or maybe even VB.NET, they provide almost everything that you need to build a website. And of course, you can use all types of external frameworks or tools or additions to make it better or add to it. With this, it kind of feels like it's more dependent on open source projects that are available.
Yeah, for sure.
I'm not saying it's a good or a bad thing.
No, it is open source initiatives, not really provided as a framework by, for instance, Microsoft, but it's all the hard work of open source contribution.
Yeah, which is actually, I think, a good thing.
Yeah, it is.
It's nice to see that the ecosystem has grown this far since, like I said, all the way back when F# was first introduced. It felt like it could use some extra love.
Yeah, and this is that love.
Nice.
So it's not really one that fits into at least the whole safe stack, but I think it's really a cool one.
I'm seeing WASM, so I'm already happy. This
is really cool. I want to show you this one as last. So it's F# that uses Blazor to give you WASM.
Wow.
So it's a different way to look at client-side code. So no JavaScript, it gives you back WASM, and this is one that it also uses Elmish. So you see that Elmish itself is agnostic of what kind of rendering technology there is. You can still use this. Yeah, but I think this is also a really cool one. So F# can also produce WASMs.
Nice. So it's really becoming a full-featured ecosystem around the awesome language that is F#.
And I hope I gave you some interest and points to look at and to maybe dive deeper into this ecosystem.
Yeah, I think my next weekend might have been filled just now.
Cool.
So thank you so much for this introduction. Thank you for watching. We'll see you next time.
Thank you for watching. Bye.